Hello guys, welcome to this particular problem of solving LeetCode questions. I started solving this question and I was just checking it out and I thought let me just record a video for me. So that's basically the last thing that I was doing. I was just testing out some thing before I wanted to start solving it. Then I said let me just add it to my collection of videos. So today we are going to be tackling multiple strings. Given two non so you rate given two non-negative integers nums1 and nums2 represented as string, right? Return the product of nums1 and nums2 also represented as string. Note, you must not use any built-in BigInteger library or convert the input to integer directly. You have examples like that, 2 3 equals to that, then that equals to that. And then the constraints, the length of nums1 and nums2 will be 1 to 200. So you can have like 200 characters within there. So you can have like very very long integers also. Nums1 and nums2 consist of digits only. Okay, and then we have like both nums1 and nums2 do not contain any leading zero except the number 0 itself. Any leading 0 except the number 0 itself. That's interesting. Anyway, so I was trying to find a way, and okay, what I was trying to do here was just like try to find a way in order to convert like a number into digits or stuff like that. But that itself is so they say we are not converting the input into directly into integer, right? So we're not going to use integer here to convert the input. We're also not using a BigInteger. Obviously, since it ranges between 1 to 200, it's going to be definitely bigger than an integer. We're talking about a very astronomically big number here, right? So even if you are to convert to an integer, that's like so not possible actually, right? So what we can do is return to our old multiplication way. So if you study multiplication in school, then if you're given like a number times another number, right? Or let us say 4, 3, 2, 1, right? Then we'll have they used to tell us to do something like this, or just right, and then we'll have like the multiplication sign here. We'll have something like so I think it'll be it starts. It's been a while. It'll be like I think it'll be like 4, 3, 4, 3, 2, 1, right? So and then we're going to have something like if I'm not mistaken, yeah, that should be it. And then we'll start like the multiplication here. So we'll start like we'll do 1 times 4, which will give us 1, right? And then 1 times 3, which will give us like 3, not 3. Then that will give us 2, and then that will give us 1, right? No. So that's something like, so that will give us 4 here, not 1. That's why, yeah, so something like that. And then we'll take the 2 beneath here, and then we'll have like 2 times 4, which will give us 8, right? And then we have but remember it goes under, so it doesn't start. So like it's, anyway, let's continue. We'll figure out how to do this in algorithm. So 2 times 4, which is 8, 2 times 3, which is like 6, right? Mm, then 2 times 2, which will now give us 4. No, no. Yes, and then 2 times 1, which will now give us 2, right? And then like we'll just like continue the same thing. So here again we have something like 3 times 4, which will give 12, right? Which will be 2 and carry 1, right? Take the number on the left, so it'll be like 2 and carry 1, and then 3 times 3, which is 9. That will give us plus 1, 10, so it'll be 0 and carry 1, right? And then 3 times 2, which is 6, plus 1, 7, right? And then we'll have like 3 times 1, which is 3. Is that correct? Oh, so this one will have to start underneath this one. Yeah, something like that. And then the last one now will be 4, which will start there. So 4 times 4, which is 16, there will be 6 and carry 1. So let's just do we'll have to write the algorithm to compute, to do something like this. So it'll be like 6 and carry 1, right? But this is way this is way too much. Okay, let's continue. 6 and carry. So 4 times 3, which will be 12, which will be plus 1, 13, which will be 3 and carry 1. Then 4 times 2, which is 8, plus 1, 9. And then we're going to have the last one, 4. Right. Then we are going to have the addition that is going to give us everything here. Right. So basically, this is the process that we'll have to do. Okay. We have to replicate at least something similar to this if we're not allowed to use like big integers, and we're also not allowed to convert the inputs directly to integers directly. But can we convert each of them one by one? Yes, I think we can cast them to integers, right? So we can cast the. So what I want to do, let me see. Can we cast? So system dot print system dot out dot print. So we're just ln of where int int of 2, int of 2, since we're going to be times 2. Not sure how that will work. Okay, let's have a return statement here. Return just like an empty string to check how that works. think I have slow internet connection. Very slow internet connection. Yep. Oh, the out should be that's 100, and that's weird. That is weird. Let me see. Google, how do I convert from character to integer in Java? Like I thought like casting a thing would work, but it's giving me something else. I have no idea. I don't know why. Oh, minus zero. Okay. I figured like casting the entire thing to an integer would do the trick, but yeah, it's still giving me the same thing. I don't know why. I have no idea why. Okay, I have no idea why. Do I mean I don't know. So it's like you know, give me like 50. Yeah, give me 50. So uh ch equal to hold on, what do you say? Int num. Okay, so I just do int number equals to, so I have like 2 minus 0, then the number equals like 5. Except of course it requires me to hold it in a character, something like that. I have no idea. Yeah. So I'm thinking that it definitely requires me to hold it in a variable first. Then use the variable to minus it from this. It's just so much long process and too many memory. Why is it giving me 50? I don't know. I don't understand. Okay, at this point in time, I really don't understand why it's giving me 50. And it's been giving me these outputs for a long time. I don't get it. I don't understand. Okay, this has been giving me this particular output for God knows how long. Even when you came, you see me getting some weird output. I don't know why. Oh, minus 0 character. So the 0 itself has to be a character. Now that's interesting. So I can do this. Oh, come on. Can I do this successfully? And if so, can I do that successfully? Yeah, I can do that successfully. Can I do this successfully? Yep. Yeah, okay, so I can do that successfully. Okay. So first things first, I'm thinking that now if you look at the way we multiply this, we're definitely starting from the ending, right? So we're starting from the ending of the one, multiply it from the ending to the first, starting from the ending of two, multiply from the ending to the second. But again, that's a lot. If we do this for the short, for like something like this, it will work. But say we have like 100 character, the 100 character there, then this becomes really long, right? And then the mathematics here it becomes a lot. And if I have to shrink the mathematics here, right? Again, like what type of integer are we going to use to hold that? So, assuming that we have to stay within only when we are doing the computations, but at the end we have to stay within the string format. How do we do that? Definitely it's 1 times all of that plus 2 times all of that plus 3 times all of that. So like 1 times all that will give us 1. Alright, so for each time we multiply, we're going to have an initial value. Right, so okay, what I'm going to do is I'm going to have something, right? So I'm going to have something like add. So private the function, I'm going to have a supportive function. Private is going to return a string, right? And it's going to take add two strings of numbers, right? So and again we are going to take string of num1 and string num2, right? And the idea is that we're going to iterate, right? And so the first time we'll iterate, right, we'll take this and we're assigning it to the base tree, right? So the next time we iterate, we're going to take the base string that already exists and add and take the whatever we derive from multiplying this by this number to to the base string, and so we just keep adding and adding and adding and adding that. Right, so that's what I think we'll do. But you also have to realize how we are adding. So it's going to be, so here is definitely going to be like 0. So we're going to add 1 to 3. And we also need to add like the 0 at the end here. Right. So each time For the first time, we are going to also make to add we're going to multiply it by 1, and then the second time I multiply it by 10. The third time I'm going to multiply. So we're going to multiply by 10 to the, we're going to start at 0 and we're going to multiply by 10 to the I, and I is going to start at 0, right? So each time we increment one round, we're going to multiply 10 to the I, which I 0 is going to be 1. No, yeah, 10 to the 0 is 1. Anything to have I even forgotten? Anything to the 0 is 1, right? Let me confirm. Just so it should give me 1. Yeah. Anyway, don't worry. You have moments like this where we forget simple mathematics. But like I said, it's a progressive thing. So, so that's what I want to do. So you have to derive a formula for this function, which is add two strings of numbers. And in essence, we're going to have now the two strings of numbers. We're going to have definitely it's going to be one. The base is definitely going to be 1 more than the next one. So we're going to assume that, so we'll just put this as base, and then we're going to have num. So we're going to have number. Right? So the base is going to be is going to have 1 digit less than. We can assume that the base will have 1 digit less than. So we're going to assume base will always have 1 digit less than the number, right? And then what we can do, and because of that, we have to account for that 1 digit by adding 0 to the base, right? Yeah, we have to account for that 1 digit by adding 0. No, do we? Do we need to? Yeah, by adding 0 to the beginning of the base. Yeah. Because when we send in when we're sending in number, we're going to include 0 here, right? When we're sending in number, so we're going to include 0 to match that, right? Because normally this is how the mathematics goes, right? So you start no 0, then you add 1 0, you add 2 0, you add 3 0. This tells you the degree, the hundred, I don't know how they call it, the degree of hundreds or thousand, the degree of tens, right? That's been added there. If that's the right way to put it. So, so this is like 10 to the power 1, 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3. You understand? Yeah, so that makes sense. And so when we send it, you realize that this will definitely be the base. This is the first time we're going to go. And then the second time we go, you realize that when we send this, the base is lacking 1. The third time we go, when we send this, the base is lacking 1. So each time the base is lacking 1. So down there within the base, we want to always add, something like that, right? So we also add like a 0 here, same thing, right? 0 there. So when we send the base, we also have to do that. So that's what we want. That's why I am putting that the base is always going to have 1 0 than the number. So add the 0 before, right? And so we are going to do this plus equal to, no, we're going to do base is equal to 0. We're going to have something like this plus base, right? So we are going to have that particular digit, and then we now have a new base, and we make this makes sure that the base is now equal to that number. Right? This makes sure that the base is now equal to this number that we are sending, and now we need to add both of them. And we start adding from the left. Okay, so that's where we start adding from, to the right. Again, we say we are not converting the input to integers directly. So still, this is technically not the input, right? This is technically not the input. These are not the input. So these are basically working numbers. So we don't need to be fragile with this one. So we can do, I think, we can cast. Well, if that's too long, then like, because if we get like a 200, right, that becomes really long, and no matter how we cast that, that digit will not exist. It's going to get truncated. So we just want to iterate and mathematically add each of them, right? So, and that will be so will be len. So integer then equals to base dot length, right? And then we're going to do like a for int I equals to 0, right? I less than length, right? I plus plus. We need to iterate gradually, but well, no, actually we want to start now. Now when we are adding, we don't start from here, we start from this other side. So I is equals to len here, right? And then I is greater than 0, then I minus minus, right? Yeah. So we start from both and go downwards. So we are going to add we are going to do, so we're going to do int character base, right? So let's just put character base CB, which is equal to we're going to initialize it there. I'm going to have int to, it will be like the int character number, right? And this will hold our integers to add them, right? So it will be C base will be equal to the char at, let me see, it will be base dot char at I, right? Well, kind of like this, just so I minus 1 equal to greater than or equal to 0. Yeah, so yeah, I minus 1. So C base start at the end and goes so again the character at that, it will be minus 0 again, right? So that's going to give us our integer, right? From what we saw in that demo right there, this thing. So we get the character minus 0 is going to give us our integer. I'm going to have C number equal to same thing, we're going to have number dot char at the character at I, character at I, I'm going to have it minus 0. Okay. So now that we have both characters minus in each other, so we have both characters and integers, right? We are going to check. We're also going to have like int remainder, the remainder equal to 0, right? And we're going to check if remainder. Let's put shorthand. That's a lot of words there. If remainder, so we're going to is it remainder, hold on. Yep, I'm facing issues. It's remainder. Yeah, remainder. Yeah. So if the remainder is greater than 0, okay, we want to, oh no, it's not even remainder, it's carry. Yeah, carry. So carry, sorry. So proper naming. If the carry is greater than 0, we want to do so first of all, we want to do new number. So we'll do sum int sum equal to 0. Right. So we'll have sum here. Forward this sum. Sum will be equal to CB plus CN. Right. CN. If carry is greater than 0, then sum plus equal to carry. Right. We don't care after that. And then we also need another if, because now we are checking. So this first one checks if this is greater. So now we are checking if whatever this is greater than 10. Well, it's greater than 9, right? Because if it is greater than 9, then we have to take the number of the left and carry over the number on the right, right? So and then at the end of it, we have to put them all in a string. So definitely the result. So the string result will be equal to an empty string. Yes. And then
Hello everyone, welcome to
yes. Sorry about that. I was following some SQL tutorials just to remember some few things. Anyway, continuing. Yeah, so we're adding two numbers. So when we add the both, like here, we want to put the number on the left. Okay, so put the number on the left, and then we'll carry the one on the right. We'll put the number on the right, and then we'll carry the number on the left. Right. So we want to check if sum is greater than 9. Okay, if that's the case, then what we want to do is result equal to, oh no, so the first thing we want to do is, what do we see? We also have like a temporal sum here, a string, to convert this to a string. Let me see. A string temp equal to an empty string. And we'll clean this up later. So we'll have like temp, convert the sum into string, will equal to sum. Something like that. Right. Um, and then this will definitely give us a string, 2-character string, and I want to take the character at the end. So 0, 1. So it will be result, and whatever number we are adding, we want to add at the front because we're adding from behind going in front, right? So where is it? We're adding like this, going like this. So whatever resulting number, we are basically just taking the new value and adding it in front of all the existing values. So it will be result equals to temp, right? Temp. So this one says that the value at sum is definitely greater than 9. So this value here, we have to get a temp of at 1, not at 0, because the one on the left is at the index of 1. Oh, sorry, temp dot character at 1, right? And then we're like plus result, result. Hopefully that works. I put something, check proper conversion. So we'll check that while I'm still in my logic. Let me not disturb things. Else, we will simply just do same thing, but we will not do character add. We'll just put like temp plus result. Technically, we can just like do the sum, right? We don't have to every time. We can only do it. We can just do it just here, right? We can just do it just here, and so here we can just do sum plus result, which is the same thing here, or result plus sum. Yeah, sum plus result. We can simply just put the empty string there. I don't know if we need the string before the sum. I don't know, but anyway, let's always do that. So kind of like a force of habit. But we can also check when we're running it to see if that's the case. If we remove that, then it's going to break or something. But that's so. Yeah, what we are trying to do is add the value to the result, and yeah, what we are trying to do, determine, check for carries. Applicable. So this should efficiently run this. You take the two values like 4 plus that will give you 4, and it will simply just add here, right? Because sum is less than 9, so it's just going, it's less than or equals to 9. It's less than 9, so it's going to just add it. Result, which is empty plus sum, which is going to give 4. Right, just going to have like a single 4 inside there. Yeah, and then it's going to go now to the next one, and this is going to give you 11. It's going to take there's no carry, so it's not going to bother about that. It's going to take the 8. It's going to take the 1 on the left and it's going to carry 1, and it's going to put the one on the left right here, result. I don't know if this, again, same thing here, but this is a character, so that doesn't have to apply here. It's like character plus sum, and that will give you 42. So that will give you like so that 4 in front of that will give you like 14, 1 and 4. So if you're supposed to add this, you should have 4, 1 here, and then you have, so you have 1 and 4, and then you have like, that's 8, and then that will be 9. Same thing, because the carry, it handles the carry well. It's going to check if the carry is equal to 0 and so on. Yeah. Anyway, so, and we should be able to return result here, right? And return result. Now that's within the 4, so that will not return result out there. So that's a lot. And the moment, so we, so we have to set the carry here. So we have to set the carry be equal to temp, sorry, character now 0, and then this will always be 1. So we have character 0, and then temp, we set temp back to the, yeah, at the end here, we just set the temp back to an empty string, because we really use the temporal here for what it's supposed to be used, right? And we're getting a carry. And what's the carry? Carry is an integer, right? And so it will be character minus 0, minus 0. So that converts that character to an integer, and it will set the temp back to string, an empty string, so that when it comes back here, it just converts that. Yeah. And so here, when we do the carry, once we add the carry, we want to set carry back to 0, carry equal to 0. Yeah. Because we're not using carry again anywhere else. So that, yeah, okay, so that works well now. So that's the first thing I want to do. So if I do, so let me do, say, let me add 2 numbers. Right. Let me do 1, 2, 3, 4. Right. And 4, 3 to 1. Right. And then see what that gives me. Alright, so it's carry, which is just double arrow, but and so we're going to have the same problem, yeah. Why? If it's just one letter, why am I even? I don't know. Make more sense to just put the one letter than to remove it, right? So yeah, you have to carry there. We're going to use to check the carry here. We're going to reassign back carry. Yes. Alright, so let's hope that that works well. Index 4 out of bound for length 4. That's weird. It's supposed to be like index 3. That doesn't make sense at all. See, number, character, over. But this is a number here. There are 4 of them. 4, 3, 2, 1. 1, 2, 3, 4. It's exactly the same. I don't know what's happening here. Oh, I see. Okay, so it's supposed to be 1, 2, 3. Yeah, so it's supposed to be one short. Sorry, so we did not follow that because we're having like the same. That's what we passed. It's supposed to be one short. So 1, 2, 3, 4. Yeah, now it's going to run. I made a mistake when passing it. It's correct. I just made a mistake when passing in the value to test. So we should get like error here, yes, but we should see what's added here. 4444. Huh. Okay, so it says 4444. So let's do a computation. 1, 2, 3 plus 4, 3, 2, 1. All right. 4444. So that's correct. So as you can see, our computation price here for adding 2 numbers is spot on, right? So now that we have that function done, we have this part done, right? That's incrementing. What we need to do is now multiply this. We are going to take the. So what we will do is we're going to run a loop function. We're going to take this one and multiply it by everything in it. Okay, and multiplication is going to be, we're going to multiply every value by every other. So this allows us to be able to always have something like this, like just one value multiplied by all the rest of the values. And so we can do this easily by say 1 or whatever number is here times 4 times this times this times that, right? So it's just the same principle as addition when it comes to carry, right? It'll be 1 times 4, 1 times 3, 1 times blah. I'm also going to have like the carry stuff. So so in other words, let us see how we can accomplish this feat by how do we do the individual multiplication. So we are going to obviously find the length, compute the length of the numbers, right? So len have num1 len or int num1 len be equal to num1 len, right? And essentially that's num2, same thing. So num2. So we now have the length. Let me space below. We now have the length of num1 and num2, right? What's the next approach? Okay, of the length of num1 and num2. So 1 times 4, 1 times 3, 1 times 2. We know that we're starting at the end, and we're taking 2 times 1. So we're taking nums2 times nums1. We can go any other way, but how do we want to go with this? Do we want to go nums2 times num1, which is easier, right? Which is easier. I think it will be the shortest that will be here, because the shortest will give us the less computation down here, right? And then the longest, so we'll have we'll do dividend and divisor. Let me see. But anyway, we're going to iterate the same thing, so it doesn't matter how we want to iterate. The iterations are always going to be exactly the same, right? Because right here we iterate, right? Because we select the shortest here. Say we have like this one is shorter, then we're going to have less mathematics, but we're going to have the same computation here. If we put opposite and this one is shorter, say this one is shorter, and then we're going to have less multiplication here, right? But more addition here. So it all depends on the computation. So we have to, should we extract it to another function? That's the question now. Or do we just leave it in the main function? It is pretty interesting, right? Because extracting this one made it very clean, right? So we can multiply a number. We also have to have result. So we have like string result will be equal to an empty string. Yes. So we can multiply. So what we can do is multiply each digit of nums to all digits of nums 1 and add the result, right? And that's a multiplication. So if we do, so it'll be like 4, sorry, 4 so what we can do is have another method here called private, right? private that returns a string of numbers, right? Private string multiply strings, right, of numbers, right? And we have a string of, say, base number. I don't know, is it like the multiplant, or how they call these things? Um, how do they call? Let's look up proper values here. How do you call the two actors in multiplication? Is it multiplication? The multiplicand and the multiplier, the number that is being multiplied, the number by which, yeah, so for example, 6 is the multiplicand. So we're going to use this particular names. So the number that is being multiplied will be our base, and then we're going to have the what's this multiplier. So at least we should. Multiplier will always be a character. It will be like a single. It will be a character, right? It will be a character. So like a character multiplier, and then the multiplicand will be a string. Okay, and what will happen is the multiplicand is basically this up here, which is always going to be constant, while the multiplier is going to be each and every one of these digits. And you see, we're going to extract them from this for loop, which we're going to do in a bit. So, but let's first of all write this function. So the multiplicand will be, so it will be, in a sense, what we're trying to achieve will be something like this. Let's have a visual representation of what we're trying to achieve. Yeah, and will be, let's make it not 1 for now. So we're trying to do something like that. And how do we go around that? So I think it's the same thing here, right? Essentially it's a loop, it's a for loop. Okay, and it's going to be a for. Let's learn. Since we already have the multiplicand length, we can simply just pass the length of the multiplicand. Alright, so we have integer, and it will be length, right, which will be the length of the multiplicand. And then we can do for int I equals to length minus 1. I hope. I really hope that doesn't. I less than, sorry, I greater than 0, or greater than equal to 0. Right, so I have I minus minus, right, what we want to do. And so we're going to have variables up here, so string result equals to an empty string. And what we want to do, I'm also going to have like a carry. So this is going to be an int carry equals to be 0. And I think we're also going to have like a temp, right? So it's going to be a string. Will it be a string? Yeah, it's going to be a string. Then equals to an empty string. Oh, and we're going to have character at multiplicand. Let's see if we'll have that. So, because, yeah, and oh yeah, so we're going to have int. So character at multiplicand equal to 0, right? And also character that integer character at multiplier equal to 0. And then yeah, no, the character multiplicand, we don't need to, multiplier, we don't need to always calculate it, you already have it. And we can do multiplier, since that remains constant, multiplier minus 0, right? And that converts it to 0, okay? And so that remains constant, and we're always going to be multiplying it by the character at multiplicand, right? And so the first thing we want to check is if. So first we want to do the sum. Also, we're going to have like an integer, the product equal to 0, right? So just put a shorthand. So we're going to have prod is equal to, that's the product, right? The product is equal to, so it will be this one minus the character at multiplication. So we have to first find the character at this. So excuse my not so very straightforward way of solving. Again, like I said, this is not a pre-planned video. This is on the fly, so it's not. So just go with it, okay? And this is going to be multiplicand at character at, right? Character at I. Right? And remember, we're starting from the end here. That's why the I here is equals to length minus 1. That's the length minus 1. That starts at the end, and then we decrease downward, because that's how multiplication works, at least when you're following this route. We have that, and so multiplicand character at I product. Okay, so this is going to be minus the character 0 for it to be integer, right? Yeah, and so the product is going to be CMT times CMR. And of course, if we say if, we're going to do the first if carry is greater than 0, right? We want to have product plus equal to carry, right? Plus equals to carry, right? And then we have to have carry equals to 0, okay? And that is going to solve the, so we're going to check for carry and accordingly, right? I hope I'm spelling accordingly right. Anyway, and then we're going to add the product to the result and perform carry where applicable. So we're going to check if prod, right, is greater than 9 again. So in this particular case, I think there's something very interesting here. if so right here, so before I finish, you need to check if I is equal to 0, right? If that's the last input, what we want to do is that we don't care whether they have the carry, we just want to add that into, we just want to add some to the result and go, right? So this particular thing here, right? Because I just remembered you could have a situation where, you know, the last addition plus the, let's just say, carry, it's greater than 9, and if you perform the carry, you're going to have a wrong result. So in the case we did the 1 2 3, that works perfectly, but usually when you're doing multiplication, you get to see that, which is why I came to do this correction. So right here we can simply just return that, right? I is greater than 0. If I equals to 0, I've already done the carry and stuff like that. Right? So this doesn't even, this will never be touched ever, right? That will never really need to be touched because it's always going to get to the point where it's greater than 0. So that already performs the sum. We're going to do sum dot result, right? And we don't need to do any of these things. Okay, yeah. And we're going to do exactly the same thing right up here. In this case, it's just before, right? And we're going to do result equals to product. In this case, product plus result. Okay. And technically, we're not doing result. We're just going to return like that. And yeah, we are going to return like that. So that's the safety that I missed the first time. I'm sure some of you picked that up, but now we solved that. So the prod greater than 9. So we're checking if when we add any of these, we add the carry, whatever it is that we did, right, is greater than 9. If that's the case, then I want to perform similar stuff like this. We'll adjust, don't worry, we'll adjust. So I want to put temp equals to sum, right? 9 times 9 is 81, so it's always going to be 2 digits still. It's never going to be more than 2 digits, so that's good. So temp is equals to an empty string product. Let's say temp. We have temp there, and result is equals to temp dot character at 1 plus result. Yes, and then carry is equals to temp character at -1 here. That's carry, and then temp gets to be an empty string, and then result is equals to prod. If it is not, say we have like 2 times 3, then plus whatever carry that is. They will simply just add result in there. Right? So yeah, that is it. Temp result carry temp result carry temp. Yeah. So we're using the temp there. Yeah. So, and eventually, I think that's it. Let's run that again to see if we have some errors. Yeah. Okay, so we have that. Just comment that out. Okay, so we can just return. So we have to do a return here. So return on result. Um, it's never going to be hit, but the algorithm is complaining. So you need to do the return. Because of this value here, it's never going to hit it, right? So um, yeah, where since my column. I'm just running it to make sure that the correction, the addition I did there didn't break anything. Yeah, it didn't break anything. That's still good. Okay, so we have our multiplier and our adder, right? So right here, we need to iterate, right, both. Now we can adjust for the shortest or the longest, but at the end of the day, I think which one is better. You see, it's still the same algorithm, the same thing. So I don't think that whether or not we take the shortest or the longest is still going to result in the same amount of iterations, amount of cycles that need to be done, right? So except of course addition is much complicated than multiplication, then we'll try both. We'll try both. But for now, let's just choose at random. Let's assume we're going nums1 times nums2 times nums1, right? So nums2, this will be nums2 and this will be our nums1, right? So let's do that. And essentially, um, if we are doing that, then we want to always use the length of nums2, right? And then we'll pass in the length of nums1 for the multiplication. So we want to do for I, for int, for int I equal to, so we are again starting at len minus 1. So len of nums2 len minus 1, minus 1, right? I less than, or I greater than or equals to 0, right? I minus minus. What do we want to do? We want to call this, okay? And what does it take? The multiplicand, which is nums1, num1, right? The multiplier, which is num2 dot char at, char at I, right? And it takes the length, which is length of the length of the multiplicand, right? And that will be in this case the length of nums1, right? So nums1 length, okay? So that is what that takes in, and that calls that function. And we now have to, so if, so for the first time we run this, right? So for the first time, we want to make sure if I equal to nums2 length minus 1, that's the first time we run this, okay? We don't want to So we want to do that. This will be the result. So that will be the first time. Result will be equals to. Let's see. Result plus equal to that. Okay. So if that's the first time we are running this, then we just want to take the resulting multiplication and put it at the result. Else, else, what, run this one time. So put string. Oh, let me see. I could. It's going to be like I could do the same thing here. It's just that because it will be result, right? Why am I saying plus equal to? It's just result equal to. Right? Let me see. Yeah, result equal to. It's not plus there because we done a string, right? So and then the second time we simply just want to add that result will be equal to this, which will be the string, and that will be the okay. Again, that will be added one. That will be like the multiplication. Oh, okay. All right. So can you like temp, or let's say product, because yes, that's the product. Product equals like empty string, right? And we'll send it to multiply the string. We'll do product will be equal to multiply that. Okay. And then that's the first thing we want to do with the product, but it will be the multiplication of that plus the 0, right? Because again, like I said, will it be like plus 0? Be math 10 to the power which will be also have an int, and we'll have the power starts at 0. Okay, and right here I want to increment power plus, just remove that power, because remember I told you we're going to do that 10 to the power stuff to add those zeros at the end here. I'll need to add them neatly. Okay, so this will be, that's a string, and it will be math dot I think it's power. Math dot power. If I'm not mistaken, I think it should be math dot power, and then the value should be 10, and then the power, which should be power, right? Yeah, and we're going to add that to, so in this case that'll be 0, 10 to the 0, which will be 1. So 10 to the 1. So the first time we're not going to add any power there because it's basically 0, right? Right. We can add it, but it doesn't make sense since there's not going to be anything there. It's just going to be 1 times that, so we might as well just omit it. That will save us a lot of computation there. And then the second time will be 1. That's 10 to the power 1. So I think, let me see, how do you do? Yeah, mad.power. That's correct. Right. So this adds the 0 we need and puts it in prod. This is still a string. Hopefully that still remains a string. No, that doesn't. That's 10 to, that's like 100. No, 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 no. Okay, that adds 100. That's not good. That's not good. I just need the zeros. So I'm supposed to multiply these by all of these. That's what I'm supposed to do. Okay. Should we pass it? So multiply numbers. Let me see. So for here, if I'm supposed to pass power, then here, the first time I have a value, I will put so if I pass the power here, okay, you say I do something like this, power, right, and then power, then assuming that returns the appropriate, right, then what should happen here is that we're going to receive right, and that'll be math, and so this will be an integer, int. Will it be an int? Will it be an int? I'm hoping that it does. It's an integer. That'll be like 2 billion. How many zeros? Yeah. number of zeros. I don't know. Yeah, we are simply okay. What are we supposed to do here? We just need to add the number of zero. Yeah. Right. So math to the power 1000. No, 1 to the power 100. 10 to the 100. That will be a lot of zeros. Quite a lot of zeros. So I know that to form the 100, but if we're supposed to multiply this, what number is going to hold it? That's what I'm worried about now. What number holds that? Okay, this is going to add 1. Well, actually, I don't actually have to. You know what? Let's do int. That's how it's string. String power power str. Right. So power string should be equal to that, and then this is going to be power str plus equal to math power. Right, so we have that, and then we are going to do power str equals to power str dot substring. We're going to start at index of 1 to the end. Yeah, because we want to remove the 1 there, and then we are going to do our str. Yeah, that's a little bit hard coded, but that's the best way I think I can get that to go. That way we eliminate this nonsense on here. Yes, and this code is not needed here. Okay, so this way we don't have to pass anything here, and our stuff remain the same, and this allows us to add the amount of zeros we need to our prod. Then remember, we need to now send it to our addition with the result as the base. So our addition takes 2 functions. Right. Our addition takes 2 parameters, 2 arguments. So we have to have a result. This will be our result, of course. Right. As our addition, add 2 numbers, the string, the base, which is going to be our result, right? And the number, which is going to be our product. So I'm just going to remove those definitions there. And then we have something like that, right? So and then at the end we'll have like power str. Do we even need it again? We don't, because each we do plus equal to. I can just have 2 power str equals to so we don't need to do again on there. So each time it just reassigns it, right? And so that works. That works well. So at the end of the day, we should have, yeah. So at the end of the day, with this, and then we increment power. Then yeah, so we could just like, let's say result. Let's comment that out. Let's try that. We just return result there. I think I have internet issues again. Yeah, so 6 works. 1 to 3 does work. I think it's going to I think we're going to have limits, space limit, memory limit, or something. Some kind of limit. Especially on those tests, those 200 kind of tests like that. Those are long. And with my connection issues, yeah, I think it probably exceeds time, something. Wrong. Well, no, that's wrong. If these ones work, then this one is supposed to work. I don't understand. Okay, let's try to follow this. So nums 2, nums 1, right? We get the length. This is 1. This is 2. So we do, where is it? Right, we do 4, right? So we're using this 9 times 2. So the first time is going to go 9, so it's going to go 81. And the second time is going to come 81 plus 81. No, it's 1 plus 800. Yeah, so that is weird because it's supposed to work. If this one works, I think if the second one works, then this one is supposed to work flawlessly. Not sure why. Let's check that again. And what are we passing? So we multiply with norms 1, which is 9, right? Let's see. So we are going to system.out really quick. So we're going to have prod for I but for iteration I is going to be it's going to be result. Yeah. So that's what I want to check. I want to check prod for iteration I should be prod, right? And then you also want to check if that adds. They want to do so probably no, it has to result for iteration I equals to result yeah. Doesn't make sense that the other one works and this doesn't work, because yeah, that if those two work and this doesn't work, I don't know, but at least anyway we'll find out the problem. So yeah, so at this point you see that it goes just once, right? So it does prod for iteration 0, and that's the problem, it does it just once. And so and this is like nums 2, right? Let's see. Nums 2 is 2 1 2, right? The length is 2 1 2 minus 1, except I don't know, because usually but that first one is showing that it's running just one time, and that's a problem. Yeah, so you say prod for it's one, that's correct, right? But showing that it's running just once, right? And the idea is int I equals to, right, I minus minus I greater than or equals to 0. Okay. And we're not returning early anywhere else in here, so that's a problem. I'm not sure why that is happening and that's behaving like that. Prod for iteration 0, Why is it iteration 0? So norms, the length of norms 2. Oh, okay, I see. There's a mistake. That's a mistake there. So when I was defining this, so some of you already picked this up, and yeah, I did not properly. So since I just like copy and paste, I did not edit it well, and that should solve the problem now. Because I was wondering like what's wrong with the algorithm? Doesn't make sense, right? And clearly it didn't make sense because of my wrong information up here. So now that should pass all the test cases. Hopefully, I think, like I said, what we will have a problem is with it's probably time complexity or something. We'll have a wrong answer again. So okay, let's see what happens there. Um, Question 9. Nonce equals to 0, 0. So right. So we have to handle the case. So we'll do a quick check. If so, we have length. If we have one for each, if so it does okay, this is where that say starts say both nouns one do not contain any leading zero except the number zero itself. Oh, that makes sense. So we're not going to have like 0, 9, 1, 2, blah blah blah, but we can have 0 to start. Okay. So we can basically check. So if we have more than, so we can assume the case that we have more than, if we have more than, if the length is more than 1, right, of any of these, then we're safe is less than 2. Do we see like length? What's the length? 1. Okay. Let's say equals to 1. 1. Or nums 2 equals to 1. Right. We want to do if, okay, so we have to do like, this is the correct way. If it's equal to 1 and nums 2 minus 0, the char at 0 minus 0 is equal to 0. Right, so I have same thing here. Nums 2 char at 0 equals to 0. Then we simply just return 0. Let's take the use case and try that again. Oh, num1. Come on. I'm like, so num1. Sorry. That's why I have that. I was wondering. Yeah, okay, so let's see. Well, we've made. Yeah, so this is the this is the error that I was hoping happened. Index 15, one time error, index 15 out of bounds for length 13. 1, 2, 3, 4, 5. That doesn't make sense. I thought it was like a time exceeded error or something. Line 55 or 52. So this is add two strings of numbers, string base. It's saying that we have an error here. Number dot character at I minus 0. What was I here? That doesn't make sense. Index 15 out of bound for length 3. How? Index 15 out of bound for length 3. I don't know. Actually, I don't know what's for length 13. First of all, I don't know where length 13 is coming from. I'm guessing it's the add. So it's a number. So it's saying index 15. For the length 13. Hold on, that doesn't make sense. So base 0, we add 0 to match up, right? The base is supposed to be equal to, it always supposed to be equal to, right? It's literal. In fact, the logic is that the base is always supposed to be equal to the number, right? That's the base, which is the result that's always being sent. It's always supposed to, because the first time it runs, this will be the result, right? The second time it runs, so the first time it runs, this will be the result, okay? And the second time it runs, this will be the result, right? And because we're adding that 0, this is what we are sending. And so the base, which is always the result, we're going to be adding a 0 there. So it is safe to assume, very, very safe to assume, after adding that 0, where is my what is the place of the error? I think it's somewhere here. Yeah, it is safe to assume that I will this value will always exist on both ends, right? It's always safe to assume that. But in this case, it's telling me that 15 is out of bounds for length 13. So the question is, why is it getting 15? So that's my question. Why is it getting 15? Because in what world is index 15 out of bounds for length 13? And that's Cn. And we're getting C base. So somehow, what's happening here is that somehow we are somehow the length of these two are different, which, as I earlier stated, does not make sense to me. Okay, so if I say system dot out dot print line, right, and we go base, that will be base, base. Not even sure if, okay. So first of all, not sure why we have a point as a number, but again, that seems to be like something. Why are we having number as, why are we having a point? Okay. So the base number, so let's get back up here. Okay, so apparently this prod is not properly it's not added properly. If I am correct with this, 10 to the power, so let us system.out, let's system.out this 2. Right, so it will probably be, yeah, so oh, oh, I don't know if that works. I could cast it to an integer, then to kind of like a string. Okay, yeah, it does work. Okay, so that makes sense. Let's see. let's just comment out because I was wondering, doesn't no, it doesn't add up to me. So it was definitely the casting, how the numbers were. Wait, there was something. Oh, come on. I mean, not even technically, not even this is supposed to work. Okay, what's the problem now? What's the problem now? This doesn't even have to look as if there is a problem. This, I'm just tired. This is not, doesn't even have to look as if there should be a problem here. This doesn't have to even feel like there should be a problem in simple calculations like this. So I don't even know what. Let me see. Let's check. Um, this is no longer useful. Let us. Yes, I commented some stuff here. Let us. Let's check where the error is coming from, because at this point, if you have four, that's that's supposed to give us something, right? The first time is supposed to give us system out print ln. No, no, I think these errors are just here to annoy me. Prod for duration I result. Some particular issues that these errors are here to annoy me. Let's see plot again. Duration I. This is plot. And then I have like add two. Okay, so let's check that. Okay, so the first time we have first of all it's running 3 times. Okay, the first time prod for iteration I 948. So 4 times 2. So let's do 4 times 2. That 4 times 2 37, right? 948. That is good. Okay. Prod for iteration 1, which will be 8 times 237. 1896, and I will add the 0 there. 1896 plus, hold on. 1896 plus 948. $28.44. Yes. Oh, but that is not correct. That is not correct. So it's 1896.60. So we minus 1896. Right. So it'll be plus 1896. Sorry. Where is this? Oh, come on. Where's the back button? Eighteen ninety six zero. 19903. So it should be 18960, right? So oh, I see. Okay, I see the flaw. It's a bit nifty. Is this assumption here? The assumption I made down here, assuming, so it's this everything works, but it's this addition that doesn't work. The assumption I made that down here, so we are definitely sending the right number, but we are assuming that by adding 10, the base will be the same thing, which is not the case, right? It's not the case. So I think that by adding 10, it's that neat. Sometimes, usually when it comes to like multiplication numbers, it gets a little bit. It's not always as neat as this. You get, it's not always as neat as this, and that's the idea. So this one is neat. So sometimes you can have like 12 here, right? And so you're going to have something like that. Okay, and it's not always as neat. So you see, like what just happened is exactly this scenario, and so by adding this 10, we calculate and we end exactly here, which is wrong. So we need to update this formula down here to actually discard but this is correct. By adding this 10 is all right, but we need to okay. So what is going to happen is we are going to change this, and essentially we are going to add each of them by assuming the length of both. So we're going to put int base length equal to base dot length, right? And int num length equal to number dot length. Okay. Then what is going to happen is the length. So the length is going to, the length we're going to use is going to be, so length is equal to the max math dot max of base length and num length. Okay. And so we are going to perform let me see. Because the addition will be, we're adding two of them. How do we, let's visualize how we're adding. We're adding like this. We want to add, add. And at the end here, you don't just want to, like, yeah, we don't just, okay, so what will happen is, I think we are going to maintain the same thing, but we're going to check if, no, we're going to, maybe we're going to, no, what, let's do this. We're going to do something like if base length is less than numbers length, which it will be, we want to add the number of zeros needed so that we can properly conduct that. So technically this is, right. Then the number of zeros will be below 4. I'll do like this, 4. Int j equals to 0, j less than number of nums length minus base length j plus plus, right. We want to put base, I want to do this, so this we can also, yeah, then should be equal to normal length. Let's try that. There we go. Oh, come, I don't know what to do anymore. Seriously, don't know what to do anymore. Um, what can be the reason now? I don't even know what to calculate. Okay, the output is not even, it's just too long. This test case. Is there a problem? I don't know. Because this one adds the proper zero, maintaining our base, removing the initial zero. And this code here gives us the proper power. So theoretically, this should be working right now. Because to manually debug this thing is, I don't know. I have no idea what to do. Even if I am to put back this stuff, it's going to take me a lot of time. I am not even sure that that will even begin to solve other issues that look like the code just have continuous issues. Look at that. Right. So there are how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Is it like 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. Starts from 0, right? So this is 11. It says that prod for iteration 11. Let's check that out. So how this times 3. 1, 4 to the 6. Seems like a lot of people have been stuck on this number. Because, yeah, this is just, yeah, seems like a lot of people have actually met this, because this is like a whole LeetCode problem here. It's like exactly the same problem. So I'm guessing that number has some kind of a deal. Mm, we're working with strings, so it doesn't really matter how big that thing is, right? So since 1496486. Alright, so it's rounding up. So I guess this is correct. And then so you have another 3 again, and then we'll have that number plus that number. If there's a problem, I'm guessing it's going to happen. So if that comes out correct, then I'm just going to ask ChatGPT, because I'm going to tell you right now, I will not have an idea on where the problem is coming from. So if that does not come out correct, so 6461346, 6461346. So I'm guessing that is correct. Okay. I'm guessing that is correct, and it's correctly adding. So the question is, what's the business with giving me wrong values at the end? There's something. Yeah, so what's the business here? This correctly adds, where is it? No. This correctly adds the 0 to the base in front of it. Okay. So if we do a system out, yeah, system dot out, print ln, and we do a base, use base. Then we should also be able to see the base alongside the product, right? That should give us a decent idea on if we are properly adding those zeros. Slow network connection. Come on. Okay. Yeah. Yes, so that adds that. Mm-hmm. Let's check those other cases. I think there's one case here that was, yeah, so this is the case that I was looking for. So at this point, not sure what the problem is. I don't know. I've not checked. I've not really gone through every single detail because Google is not giving me the exact value. They are just approximating this thing to the stuff. They're not giving me the complete value. So the issue can be within the remaining values, so I'm not certain on exactly those values. But from what I look at, the first two, they are correct, and they are correctly adding the zeros right in front and also behind. So at this stage, I have little to no idea why that is not working. So and why this is a problem. And I sort of saw yes this particular problem here. Blah, blah, blah. This one is just we'll look for. Let me ask GPT for my own stuff. So um do hey chat. This is LeetCode 43. No, I don't think this skips checks use. If sum is greater or equal to 10. Okay, so essentially my power is wrong. So I had the right approach, but generating power, I think this should be like the main issue. Okay, it should be like essentially the main issue. So let's check that. Mm, yeah, now that passes. Another wrong answer. That's so not good. So where am I failing now? Oh, I passed. Okay, good. So I knew that I passed that. Okay, so like I said, the idea was good. I just forgot about the math thing. Again, coding is not easy. It's There's a lot of things to remember, a lot of things to track, and sometimes you're just going to skip some kind of things um, like the math dot power tool. Initially, you see me cast it to an integer before multiplying at some point in this video, and you realize that the math dot power tool returns a double, and so you have to cast it. And then there's also like there's also like the maximum value that it can hold, and that was the issue. That was the main issue. Now, this our solution is terrible, obviously, horrible. But this is good because it shows that our approach made sense, our solution made sense, just that we missed one small problem. And fantastically, this is one of the use of AI, and you get to see the beauty of AI. So we had a great understanding, a great approach, we had a great method, just that we could not figure out some issues which is lost within our code, and AI came to the rescue. And as you can see, we did not need to change much, we just needed to change the way we generated our power, which is initially just by generating the power manually, such like this, right? And this allows us to do the power manually. So this is really great solution, great approach, and this is like 2 hours 30 minutes has shown the grit that we have, the errors we've been making, the frustration of coding, and then it's not working and all that. And I hope that this video clearly explains this approach. This is not the most optimal approach. As you can see, we are dead last right there, and this is like the most optimal. These are some of the most optimal approach. I think these ones will probably be using we're breaking the rules, but um, nonetheless, our approach works. It is acceptable and it is good, and this is fantastic. Now we can go ahead and actually learn the most optimal approach, and this is what I'm going to post. Um, and although it's not as flashy as it's supposed to be, but it's always nice to first of all stick to what you did, and then you learn the new things, right? And this is really a great example of how we solve problems and grow. So we're going to ask GPT. So as you can see, it gave us this other section about this skipping of stuff, and I don't think that we do that. We don't do that at all, right? So it gave us a solution here, and it also gave us a solution somewhere in here. I think if we apply this one, think the carry still works, right? The carry still works. It's just going to be, does it change? Does it change anything in our speed? Let's see. Right, we want to analyze if the carry does anything to our. I don't think it would do anything. I'm just throwing a Hail Mary here to see if it does anything. Obviously, it's a more efficient code that it has given us, obviously. And then there's the addition part to add to integer. Again, more efficient solution. Well, less code, but I don't think it's let's see, will it make a difference? I doubt. I think it's going to be dead last, but again, just have to see. Yeah, it's internet connection, so don't. By the way, for those right now, for the remaining amount of time, I think for the next 5 to 10 minutes, I'm just going to pull up on ChatGPT the most efficient approach to solve this problem. So right now, if you enjoy this kind of videos, give a like, comment your own approach that you will likely take, how you will likely solve the problem without looking at ChatGPT or any other solution, and also comment what you think and what question I should solve next. Um, like this video, subscribe and share. Subscribe to the channel, click the notification bell for alerts on when I upload new videos, and then share the videos to your friends so that they should see a realistic point of view of solving problems on LeetCode. So while we wait for this, I don't know what's happening. It is. Yeah, so internet connection is definitely an issue now. Yeah, again, dead last, like I said, it didn't change anything. It doesn't change anything. I'm not surprised. It is dead last, of course. So it's not exactly, I like to keep my solution. So yeah, I like to keep my solution. Um, However, what I want to do now is yeah, I think this is the main problem why I feel this carry it wasn't any issue because I think I did that carry well, just in a different way than it did it. I think the same thing, just different way of writing it. Can this approach pass? Absolutely yes. With these fixes, yeah, definitely pass it. The most optimal way to solve LeetCode. Key insight: when multiplying two numbers, each digit multiplication contributes to a fixed position in the final result. Huh. Instead of creating partial strings, adding strings repeatedly, managing shifting manner, we can use an int array of size n plus M. Store each multiplication result directly at its final index. Do carry propagation. So core idea, their product contributes to result I plus j plus 1. Carry goes to I plus j. So let's see. Norms 1, 2, 3, norms 2, 4, 5, 6. Indices 1, 2, 3, 4, 5, 6. Result array size is 6. Each product lands in a fixed slot. So time space complexity will be handle 0, case early equals to 0. Alright, so I see what they're doing there. Anyway, you should go through this. I'm not going to be explaining this. I know, but you should try to go through this and understand it. I think you can scroll through and see what ChatGPT is talking about, and then go through the video. The video is already long already. It's about almost 3 hours, and to continue is going to be a lot. So we're going to end it here. We've solved this problem, and definitely we are going to be solving other problems. So this was a good session. Again, subscribe, follow me on my YouTube, follow me on my Instagram, my Facebook, and my LinkedIn. Connect with me and let's discuss. So have a nice day. Bye.